Okay, so here, so let's take a look at theorem BCS and the results of that theorem here. So what this theorem states is that we can find a basis, a linearly independent set for the span of the column of A by doing the following, right? So again, by definition of the column space, right? So here's our matrix from our previous example. The column space of A is defined by the span of the columns, right? But again, it says, the definition says nothing of linearly independent. In fact, what I can see here is that this set is definitely linearly dependent, right? Because those vectors come from R3, and we are working, and there are 4 of them. So at most, they can have 3 to be linearly independent, right? Possibly. So what I want to do is I want to make the set to be the minimum size to span the column, right? So what I do is, what the theorem tells me is, all right, take that matrix A, all right, reduce row echelon form it, and then from there, I notice here I have 2 pivot columns, all right? So what that's telling me is that in that set for the column space of A, I can rewrite it by choosing the first 2 vectors, right, of the original matrix. So I'll choose those 2, and what theorem BCS tells me as a result, the column space of A can be more simply written as the span of the vector 1, 2, 3 and the vector 2, 3, 5. Okay, and now because of theorem BCS as well, I know that those 2 vectors are indeed linearly independent.